Advanced Math Lesson 12, Angles and Diagonals and Polygons, Proof of the Chord Tangent Theorem. We're going to skip proof of the chord tangent theorem. We'll talk about that in class if we have time. We're going to focus on angles, diagonals, and polygons, and we're also going to go over one more case of circles with tangent lines that we skipped on the previous lesson. So starting with angles and diagonals and polygons. Convex polygons, which are the ones we're dealing with, we remember that there's two types of angles. There's exterior and interior angles. First example I have tells us we need to find the sum of the measures. Let's move this over. Or example 12.1. We need to find the sum of the measures of the interior angles and exterior angles of a 7-sided convex polygon. So they don't give us a shape at all, they just give us words. So we've got a 7-sided convex polygon. Doesn't really matter how we draw it. Honestly, we don't need to draw it, but I'll draw it for visual aid. That's one side, it's 2, I'll make this one 3, 4, 5, 6, and 7. Okay, so I've got a funny looking 7-sided polygon. So to find the sum of the exterior angles, it's kind of a trick question. By exterior angles, they're talking about these guys, right? If we go in the same direction all the way around, finding out what all of those equal. If it's a convex polygon, they will always add up to 360, no matter how many sides the polygon has. Think of it like spinning in a circle. The exterior angles will always equal 360. So the answer to A is 360 degrees, always. Now B, which is the sum of the interior angles, which is this one, this one, this one, this one, this one, this one, and this one. Well, if you're dealing with any polygon that is 5 sides or more, the sum will be greater than 360. We already know 4-sided quadrilaterals, they add up to 360. And then we know triangles will always add up to 180. And there's a bit of a trend there. The trend is that if you take the number of sides, and there's actually a formula for this, you take number of sides minus 2, you multiply that by 180, and that will equal the sum of interior angles. The reason why that is because it takes 3 sides to draw a triangle, right? So if I take away these 2 sides, I draw a triangle, that's 180 degrees. If I draw another line, that's another 180. Draw another line, it's another 180. Draw another line, 180, 180. So the number of sides minus 2 will always be the number of triangles you can fit in any polygon. So we have 1, 2, 3, 4, 5 triangles. So 7 minus 2 gives me 5. 5 times 180 gives me, let's see here, 900. 900 degrees. So the sum is going to be 900 degrees for the interior angles. Just remember this equation, and number of sides minus 2 times 180. So 7 sides minus 2 gives me 5 times 180, 900. Next, that circle from the other day. Draw it right here. Ta-da, circle. Okay. So these problems right here. We have 3 tangent lines, right? Or a circle inscribed in a triangle. What we need to know here is that these tangent lines, when they create angles, they're equal. These sides are equal to each other. So like you can see here, x is equal to x. Down here, you could say that x minus 3, y is equal to 12 right here. And then you could also say right here that 2x plus 3y is equal to 16. Okay, now all we have to do once we've written these 2 equations is then use elimination or substitution to solve for the missing pieces. So I'm going to go ahead and use elimination because I've got these 3 y's that are already opposite signs. So if I add x and 2x, I get 3x. 3 y's cancel. I get 3x is going to equal 28. Okay, divide by 3 on each side. 28 over 3. So x is equal to 20 over 3. From here, I just substitute, and then I can solve for y. You're probably not going to get very many fractions on these problems, but again, this is just an example I made very quickly to show you how to do it. Set each half the tangent equal to each other, get two systems of equations, then start solving through substitution and elimination, and you'll be fine.